important key points, then we will solve one by one all the problems. Important key points. Important key points. What is the first concept? Now see here. Important key points. The first important key points. Till now we did the problems which are of the form numerator power x divided by denominator. Numerator power x divided by denominator. Two cases are there. When numerator NR represents a numerator, NR represents a numerator. DR represents a denominator. DR represents a denominator. DR represents a denominator. When numerator and denominator are co-prime to each other. When the numerator and denominator are co-prime to each other. When numerator and denominator are co-prime to each other. What do you mean by co-prime? Two numbers are said to be co-prime. If their HCF, it is 1. If their HCF, it is 1. All the problems, whatever we discussed in session 1, 2, 3, 4. All the problems, whatever we discussed in session 1, 2, 3, 4. Takes care of this concept. HCF of numerator comma denominator, it is 1. Second case is, what if the numerator and denominator are not co-prime to each other? What if the numerator and denominator are not co-prime to each other? What if the numerator and denominator are not co-prime to each other? What do you mean by not co-prime to each other? HCF of numerator and denominator. HCF of numerator and denominator, it is not 1. HCF of numerator and denominator, it is not 1. It is not 1. Sir, can you take few examples? See here. 7 divided by 2. 2 3s are 6. Remainder, it is 1. 14 divided by 4. 14 divided by 4. 4 3s are 12. Remainder 2. 14 and 4. 14 and 4 are even numbers. 14 and 4 are even numbers. Can the HCF of two even numbers, can it be 1? No. This is an example of the case where the numerator and denominator are not co-prime to each other. This is the case where numerator and denominator are co-prime to each other. Two numbers are said to be co-prime if their HCF is 1. Two numbers are said to be co-prime when HCF is 1. All the problems based upon this type, we discussed it in session number 1 to 4. Session number 1 to 4. Now here we are going to discuss it in session number 5. Session number 5. What if the numerator and denominator are not co-prime to each other? I hope the idea it is clear. 1 to 4, we discussed all the cases where the denominator it is a prime number, denominator it is a composite number. Session number 5. When the numerator and denominator are not co-prime to each other. Not co-prime to each other. First concept. Suppose first question is there. Remainder 1. 14 divided by 4. Remainder 1. 14 divided by 4. Here numerator and denominator. Here numerator and denominator. Numerator and denominator are not co-prime. We are going to discuss a case where the numerator and denominator are not co-prime. 14 divided by 4. 14 is nothing but 5 to 6 examples. It should be extremely clear to you. 2 into 7 by 2 into 2. 2 into 7 by 2 into 2. If they are not co-prime to each other, eliminate the factor which is common. 2 is eliminated. 7 divided by 2. 7 divided by 2. 2 3s are 6. 1. 1 is the answer for 7 by 2. But I want 14 by 4. So, eliminate the factor, make them co-prime and re-multiply. Whatever the concepts that we used in the session number 1 to 4, we will make use of the same concept. But what we will do is, 14 divided by 4. 2 into 7, 2 into 2. What is the factor common? Because we know the logic, how to determine the numbers which are co-prime to each other. Take the factor common. First we will write down the logic. Take the factor common. Take the factor common. Second one, apply remainder. Apply remainder. Once you take the factor common, apply the remainder, then remultiply. Remultiply the factor. Remultiply the factor. This is the very simple logic. If the numbers are not co-prime to each other, take the factor common. Take the factor common. In 14, it is 2 into 7. 4, it is 2 into 2. 2, take it out. 7 divided by 2. 2 3s are 6. Remainder 1. 2 into 7, 2 into 2. So whatever the factor that we took common, after we took the factor common, 7 divided by 2, it is 1. Remultiply with the factor common. Remultiply with the factor common. We will do 3 to 4 examples so that it will be clear. 2 power 37 divided by 6. 2 power 37 divided by 6. Very, very good question. 2 power 37 divided by 6. Numerator, base is 2. Are 2 and 6 co-prime to each other? 2 and 6, are they co-prime to each other? No. So first take the factor common. It is 2 power 37 divided by 2 into 3. Divided by 2 into 3. So these is nothing but a remainder. 2 power 36 divided by 3. 2 power 36 divided by 3. 3 ones are 3. What is the negative remainder? Minus 1. Minus 1 power even is plus 1. Minus 1 power even it is plus 1. We got the answer 1 for 2 power 36. But we want the answer for 2 power 37. So multiply by 2. Multiply by 2. Answer for this question is 2. 2 power 37 divided by 6. 6 is 2 into 3. 2 power 37 divided by 2 is 2 power 36. 2 power 36 by 3. 3 ones are 3. Negative remainder is minus 1. Minus 1 power even it is plus 1. 1 is for the answer 2 power 36. But I want the answer for 2 power 37. So multiply it by 2. 1 2s are 2. Third question. 5 power 121 divided by 15. 5 power 121 divided by 15. If the numbers are not co-prime to each other, make them co-prime to each other. 121. 15 is nothing but 5 into 3. 15 is nothing but 5 into 3. 121 minus 1. 120. 5 power 120 divided by 3. 3 2s are 6 minus 1. Minus 1 power even is plus 1. 1 is for 5 power 120. I want 5 power 121. Multiply by 5. Multiply by 5. Very, very important key point in this session. Take the factor common. Take the factor common. Apply the remainder and again remultiply. Whatever that is common, just take it out. Get the numbers into when the numerator and denominator are co-prime to each other. Numerator and denominator are co-prime to each other. We already know the logic. Apply the logic, get the answer. You removed something. Whatever you removed, just remove, you will get it. Some more examples I will do. 2 more, so that you will not get a single doubt in this concept. First question. Remainder power 7 square. 7 power 200. 7 power 200 divided by 98. 7 power 200 divided by 98. These are nothing but 98 is nothing but 49 into 2. 49 is 7 square into 2. So here it is 7 power 198. 7 power 198 divided by 2. 7 divided by 2. 1. So it is 1. 1 is for the answer 7 power 198. I want for 7 power 200 into 7 square. 1 into 49. Answer is nothing but 49. Answer is nothing but 49. I hope the idea it is clear. Next one, B question. There is no depth to the question. A lot of questions which I will take it. 13 power 510. 13 power 510 divided by 13.9. 13 power 510 divided by 13.9. 39 is nothing but 13 into 3. 13 power 510 divided by 13 into 3. These are nothing but 13 power 509 divided by 3. 3 4s are 12, 1. 1 is for 13 power 509, but I require 510 into 13. 1 into 13, answer is 13. Right? 1 into 13, it is nothing but 13. Now you can solve this question. Reminder 1, 2 power 96 divided by 96. 96 is 2 power 5 into 3. 32 3s are 96. 96 minus 5 is 91. 2 power 91 by 3. 2 power 91 by 3. 3 1s are 3. Negative remainder is minus 1. Minus 1 power odd is minus 1. Positive remainder will be 2. 2 is for the answer 2 power 91. But I need the answer for 2 power 96. So whatever that you removed, remultiply it. 32 into 2, it is 64. 32 into 2, it is 64. 2 power 96 by 2 power 5 into 3. 96 minus 5 is 91. 2 power 91 by 3. 3 1s are 3. Negative remainder minus 1. Positive remainder will be 2. Positive remainder 2 for 2 power 91. For 2 power 96 will be into 2 power 5. 32 into 2 is 64. Each and every example which I am explaining it in the class, kindly make a note of it in your notebook. Kindly solve it along with me. Right after the topic is over, you will see that almost everything whatever I discussed in the class, it is properly structured and streamlined, so that any book you take on reminders, you will be able to solve all the possible models. All the possible models. First example, it is clear. Second example, you don't need to do anything, just follow my classes regularly, and whatever I am saying it to you, just do it with sincerity. 5 power 87 divided by 15. 15 is 5 into 3. So these are nothing but 87 minus 1. 5 power 86 divided by 3. 5 power 86 divided by 3. 3 2s are 6. Negative remainder minus 1. Minus 1 power odd. It is nothing but 1. Minus 1 power even. I said odd. Minus 1 power even. It is nothing but 1. 1 is for the answer 5 power 86. But I want the answer for 5 power 87. So 1 into 5, it is nothing but 5. 1 into 5, it is nothing but 5. I hope the idea it is clear. 5 power 87 by 5 into 3. 5 power 86 by 3. 3 2s are 6 minus 1. Minus 1 power even, it is nothing but 1. 1 it is for 5 power 86. But I want the answer for 5 power 87. I want the answer for 5 power 87. Suppose, for example, if the question is like this. Reminder 1, 5 power 134, it is divided by 10. 5 power 134, it is divided by 10. If 5 power 134, it is divided by 10, one way to solve it is 5 power 134. 10 is nothing but 2 into 5. 2 into 5. Make the numbers co-prime to each other. So these are nothing but 5 power 133 divided by 2. 2 2s are 4. It is nothing but 1. 1 is for the answer 5 power 133. But I want the answer for 5 power 134. So 1 into 5, it is nothing but 5. 1 into 5. Answer is nothing but 5. This is the method 1. This is method 1. 5 power 134 divided by 10. 10 is 5 into 2. 5 power 133 by 2. 2 2s are 4. Remainder it is 1. 1 is for 5 power 133. But I want for 5 power 134. Re-multiply. Method 2. Method 2. Please make a note of this important method. Method 2. Whenever you divide a number by 10, whenever you divide a number by 10, you will get the unit digit of a number. Whenever you divide the number by 10, unit digit of a number. Whenever you divide a number by 10, you will get the unit digit of a number. Whenever you divide a number by 100, you will get the last two digits of a number. Whenever you divide a number by 1000, you will get the last three digits of a number. So these are nothing but 5 power 134. 5 power 134 divided by 10, it is nothing but the unit digit of 5 power 134. It is nothing but unit digit of 5 power 134. 5 power any number, unit digit will be 5. 5 power any number, unit digit will be 5. 5 power any number, unit digit will be 5. 5 square 25, 5 cube 125, 5 power 4. 625, 5 power 134 by 10. So unit digit of 5 power 134, it is nothing but 5. I hope the idea it is clear. I hope the idea it is clear. Next, remainder 1, 8 power 643 divided by 132. 8 power 643 divided by 132. 8 and 132 are not co-prime to each other. So these are nothing but 2 into 66. 66 is nothing but 2 into 6 into 11. So these 2 cube into 8 into 30. 2 into 3. 4 into 33. 4 into 33. 2 square into 33. 4 into 33 is 132. So these are nothing but 8 can be written as 2 cube power 643. 2 cube power 643 divided by 2 square into 33. 2 square into 33. Remainder 1. 2 power. These 1929 divided by 2 square into 33. 2 square into 33. So this will become remainder 1. 1927 divided by 33. 1927 divided by 33. 2 power 5. 5 3s are 14. 42. 5 into 2 square divided by 33. 32 by 33 minus 1. Minus 1 into 4 is minus 4. Positive remainder it is 29. Positive remainder it is nothing but 29. Positive remainder 29. 29 is for the answer 2 power 1927. But this for 2 power 1929. So into 2 square. 29 into 4. Answer for this question is 116. 7 power 26. Another good question. 7 power 26 into 5 power 83 divided by 100. 7 power 26 into 5 power 83. 7 power 26 into 5 power 83 divided by 100 is 5 square into 4. 5 square into 4. These are nothing but 7 power 26. 83 minus 2. 5 power 81 divided by 4. 5 power 81 divided by 4. 4 2s are 8. Negative remainder minus 1. Minus 1 power even is 1. 4 1s are 4. It is nothing but 1. So answer is 1 for this question. But I want 5 power 83. 5 power 81 I got. So 1 into 5 square is 25. 1 into 5 square, it is nothing but 25. Answer is nothing but 25. I hope the idea it is clear. This is a very, very good question, sir. Fourth one. Fifth question. Remainder 1. 3 power 37 it is divided by 12. 3 power 37. It is divided by 12. 12 is nothing but 3 into 4. 3 into 4. So this is nothing but 3 power 36 divided by 4. 3 power 36 divided by 4. 4 ones are 4. Negative remainder minus 1. Minus 1 power even is plus 1. 1 I got it for 3 power 36. I want it for 3 power 37. 1 into 3 is 3. 1 into 3. Answer is nothing but 3. 3 power 37 divided by 12. 3 and 12 are not co-prime to each other. Make them co-prime to each other. 3 into 4. 3 power 36 by 4. 4 ones are 4. Negative remainder minus 1. Minus 1 power even is plus 1. 1 into 3, 3. Next, these a very, very good question, sir. Very, very good question. Probably the best question for the day. Very, very important question. This I will discuss after I discuss a power n plus or minus b power n logic. Very, very good question. I will come back to the question after 10 minutes of a time. Why? Because this question uses the logic a power n minus b power n logic. Unless I explain a power n minus b power n logic, probably you will not be able to solve it very fast. Very, very good question. 7 power 612 minus 6 power 612 divided by 1118. Divided by 1118. Now see here. Reminder 1, 17 factorial is divided by 32. 17 factorial is nothing but 17 into 16 into 15 into 14 and so on up to 3 into 2 into 1. The definition of a factorial is, it is the product of all the natural numbers from n to 1. 17 factorial is 17, 16, 15 and so on up to 3 into 2 into 1. So these are nothing but 17 into 16 into 15 into 14 and so on up to 3 into 2 into 1 divided by 32. 2 into 1 divided by 32. These are nothing but 16 into 2 is 32. 32 into any number. 32 into any number divided by 32. Answer remainder will be 0. Answer remainder will be 0. Here 16 it is there, here 2 it is there. 16 into 2 is 32. 32 into any number. When you divide by 32, answer remainder will be 0. 17 factorial is a multiple of 32. 17 factorial, it is a multiple of 32. 17 factorial, it is a multiple of 32. If 12 is a multiple of 3, if 12 is a multiple of 3, if 12 is a multiple of 3, 12 when divided by 3, 12 when divided by 3, remainder will be 0. If 12 is a multiple of 3, 12 when divided by 3, remainder will be 0. If 17 factorial is a multiple of 32, if 17 factorial is a multiple of 32, 17 factorial when divided by 32, remainder will be 0. Remainder will be 0. Seventh, good question, where the numerator it is a multiple of the denominator, where numerator it is a multiple of the denominator. The entire concept we discussed is based on when the numerator and denominators are not co-prime to each other. What is the important learning in this question? When the numerators and the denominator are not co-prime to each other, make them co-prime to each other and do the negative remainder or any of the concepts that we discussed in the previous classes. I hope it is clear. Next one. Now, another important concept. Problems based on a power n plus or minus b power n. A power n plus or minus b power n. Very, very important concept, and some previous year CAT questions came from this particular topic. A power n plus or minus b power n. First we will see the concept. Once we understand the concept, then we do some basic problems. Then solving will be very easy. Concepts. A square minus b square. It is nothing but A minus B into A plus B. A minus B into A plus B. A square minus B square is A minus B into A plus B. A cube minus B cube is A minus B into A square plus AB plus B square. A square plus AB plus B square. Now if you see here, A square minus B square is divisible by A minus B. One of the factor is A minus B. A cube minus B cube, it is also divisible by A minus B. First point, A power n minus B power n is always divisible by A power n minus B power n is always divisible by A minus B. A power n minus B power n is always divisible by A minus B if n is the natural number. If n is a natural number, if n is a natural number, A power n minus B power n, A power n minus B power n is always divisible by A minus B if n is a natural number. Very, very important logic. A power n minus B power n is always divisible by A minus B as long as n is a natural number. As long as n is a natural number. Suppose see here, A cube plus B cube. A cube plus B cube is A plus B into A square minus AB plus B square. A square minus AB plus B square. This is divisible by which number? A plus B. What is the power here? 3. If the power is 2 and there is a minus sign, if the power is 3, there is a minus sign. It is always divisible by A minus B. If the power is 3, 3 is nothing but an odd number. Very, very important concept. A power n plus B power n. A power n plus B power n is always divisible by A power n plus B power n is always divisible by A plus B, is always divisible by A plus B as long as n is an odd number. As long as n is an odd number, A power n plus B power n, A power n plus B power n is always divisible by A plus B as long as n is an odd number. The next few minutes, whatever we are going to discuss, right, are based upon these two logics. Very, very important logic. One is key point 1 and another one is key point 2. Key point 1 talks about A power n minus B power n. Key point 2 talks about A power n plus B power n. A power n plus B power n. These two logics, based upon these two logics, we are going to solve a lot of problems. Please pay utmost attention to it. I will do as many examples as possible. A power n minus B power n. If n is a natural number, if n is a natural number, it is divisible by A minus B. It is divisible by A minus B. A power n plus B power n, it is always divisible by A plus B. It is always divisible by A plus B if n is an odd number. It is always divisible by A plus B if n is an odd number. These are the two important concepts. Based upon these concepts, let us solve some problems. I hope it is clear. Previous year CAT question, 7 power 6n minus 6 power 6n. It is always divisible by 7 power 6n minus 6 power 6n. 7 power 6n minus 6 power 6n. Can I write this question as 7 cube power 2n? 7 cube power 2n minus 6 cube power 2n. 7 cube power 2n minus 6 cube power 2n. 2n is nothing but an even number. 2n, it is nothing but an even number. 2n, it is an even number. Just now we discussed A square minus B square. It is always divisible by A minus B and A plus B. A square minus B square, it is always divisible by A minus B and an a plus b. 2n, it is an even number, so it is always divisible by a minus b. 7 cube minus 6 cube and a plus b. 7 cube plus 6 cube. It is always divisible by 7 cube minus 6 cube and 7 cube plus 6 cube. 343 minus 216, which is 127. 343 plus 216, which is nothing but 559. It is divisible by both 127 and 559. It is divisible by both 127 and 559. 559, it is nothing but 13 into 43. Any number divisible by 559, it is always divisible by 13. So these also possible. Answer for this question is all. Answer for this question is all. Very, very beautiful question and an original CAT exam replica question. Original CAT exam replica question. Original CAT exam replica question. 7 power 6n minus 6 power 6n. 7 power 6n minus 6 power 6n. It is nothing but 7 cube power 2n minus 6 cube power 2n. So 2n, it is an even number. So if the power is an even number, a square minus b square, it is always divisible by a minus b and a plus b. It is always divisible by a minus b and a plus b. 7 cube minus 6 cube and 7 cube plus 6 cube. So 343 minus 216, 343 plus 216, 127 and 559. 127 and 559.